Yeah, we're looking at the Wronskian function, and let's look at the function definition. The function f1 as a function of x, f2 as a function of x, and so on to probably fn as a function of x. Okay, the Wronskian, we use W for Wronskian of those function. Okay, f1, okay, and so on to fn. Okay, is the definition for Wronskian is just determinants of those functions, and that will be equal to what? You have f1 here, okay, f2, okay, it goes on like that, n of that, okay, yeah, f2 and then fn of that function. It continues like that. So then the next thing to do is to get the differential of this. That will be f prime of that function, f2 prime of that function. It goes on like that, and then of that function. Then you can continue. Second differential, uh, okay, of this f2. Then so so this is called what? This is called this is called uh, Wronskian Wronskian of the what of the of the of the function. Okay, we're not going to blow grammar here. We just go straight to applications of that. Okay, then the next thing we want to look into, what we are looking at, there is a keynote here. There's a keynote here that a set of function f1, f2, and so on like that is linearly independent. Okay, if the Wronskian of that function, the determinant is not, if the Wronskian is not equal to zero, okay, if the Wronskian of that function is not equal to zero for all values of x, uh, okay, for all x belong to what? Integer. Okay, and if the Wronskian is zero, then such a function is called, it will be linearly dependent. Okay, but if the Wronskian is not equal to zero, such function will be called linearly independent. Okay, linearly independent. For linearly independent, the Wronskian must not be equal to zero. Okay, so let's see some questions here. Yeah, determine whether this two function is linearly independent or not. Okay, if you want to do that, very simple. Um, it's just like the Wronskian of that functions. It's linearly independent. Wronskian of that function e2x, comma e5x, and that will equal to determinants. It's two functions. Then you're only going to do what? You're only going to differentiate one time. These three functions, you do the second differential. So this will be what? Derivative of this one is 2 e2x. Derivative of this one is what? 5 e5x. Then you what? You get the determinant of that. Okay, this line is determinant. Okay, and that will be equal to this one times this one. That will be what? 5 e7x. They have the same base. You can add the power together. Okay, then this one goes this way. That's the first one. Then minus this one times this one. That's also what? That's 2e7x. Okay, and for you to add or subtract, the power of that exponential function must be the same thing. So that will be equal to what? 5 minus 2. So that's what? 3e7x, which is not equal to what? It's not equal to 0. So in that case now, it is linearly independent. This what? It's linearly independent. It's linearly independent because the Wronskian is not equal to 0. Okay. Yeah. If you look at what we have now, we have three functions here. Okay. So if it's linearly independent, determine whether it's linearly independent or not. So what we just do, just to get the Wronskian of those functions, 2x and then e5x. So let's get the determinant of that. So that ex, e2x, e5x. So when you have three functions, that means you're going to do your differentiation two times. The first time here, the derivative of this one is what? Ex. The derivative of this one is what? 2 ex. 2. That's the derivative of this one is just derivative of 5 times that function. Derivative of 5x, which is 5 times the function e5x. Okay? Do it again if it's three functions. Do it again, that will be ex, that's second differential. Okay, this one also, that will be 2 times this, that's 4 e2x. This one again, do it again, 5 times this, that's 55 e5x. Then we can do the determinant now and get the value. If it's not equal to 0, then it is linearly independent. Otherwise, it is what? Dependent. Okay, so this will be equal to, I'll take determinant, so that means ex, the brackets, remain this 2 e2x, 4 e2x, then 5 e5x, 25 e5x. Okay, then the second one, the middle one, minus e2x, then close that place, then we have what? ex 5 e5x, 25 e5x. Okay, then the last one, plus e5x dash, close this place also, then you have ex 2 e2x, then ex 4 e2x. Okay, that's how to do determinants. It's always a plus, minus, plus. Okay, so this first one, take that one out. So to make 1, 2, 3, 4 for the first one. Okay, the second one, minus, take this number out, then cover that place. Then you have this one, this one, this one, this one. That's e2x. Yep. Okay, then the last one, that's plus, cover this place. So you have this one and this one. That's e5x, ex. Yeah, that's good. So let's do the expansion for that. So the question is determine whether these three functions, ex, e to the power 2x, e to the power 5x, is linearly independent or not. Okay. Yeah, for the first one, having ex in the brackets, this one times this one, that's 2 times 25 times 2, that's 50. Then the exponential is 7x, then minus this one times this one, 4 times 5, that's 20, then e7x. Okay, then second one, minus e2x, then this one times this one, that's 25 e6x, that's 25 e6x, then minus 5 minus 5 e6x also. Yep, then plus finally the last one, so that will be equal to e5x into brackets, that will be 4 e3x. Ex, this one, the exponential is the same, just add the power together, so that will be 4 e2x, 4 e2x, and then minus 2 e3x. No, what am I saying? That will be 4 e3x. Okay, then minus 2 e3x. Let me quickly make an extraction. Don't forget that ex times e2x. What you are doing, the exponential, the base is the same. Just add the power together. That's e3x. Okay? And whatever there's a number here, the number will be with that. Okay? So, and before you can add or subtract the exponential, they have the same power. Okay? is addable or subtractable. 50 minus 20, that's 30. That's 30. That's 30 is 7x times the one outside. That's E 8x. Okay, then minus 25 minus 5. Let's problem with the second one. Let's check that second one. Okay, that's 25 is 6x minus 5. That should be 6x also here because we have EX times E5x. Okay, check that multiplication. So that will give you that. Okay, so that's 20. That will be 20 E6x. That's 20 E6x times this one. That's we have E2x into bracket 20 E6x. Don't want to make mistake there, so I'll take it one by one. Then here, the last one, we have E5x into bracket 4 minus 2, that's 2, 2E3x. So finally, we have here, we have 30E8x. Then this will be equal to minus 20 E8x, and then plus 2 plus 2 E what? E8x also. So that will be, we are going to have our answer is a 12 E8x, which is not what? It's not equal to 0. So it is linearly independent. Yeah, that's 12. 30 minus 10, 30 minus 20, that's 10, plus 2, that's 12 E8x. So it is what? It's not equal to 0. It's linearly independent. It's linearly independent. Okay, so that's that on Wronskian function. So that means that's that on Wronskian function. And don't forget what I said. If you have two functions, you only do the differentiation one time. You write the function, then you do the differentiation. If you have three functions, that means you write your function, differentiation will follow, then second differentiation will follow, and that's that on that. And you must at least have some knowledge on how to do determinants. This line is determinants. So this is determinant line. So that's that on Wronskian function.